Right now, in architecture offices around the world, a familiar scene is playing out. A designer sits in front of a Grasshopper canvas, completely stuck. The logic is fully formed in their mind, but translating it into connected nodes takes 3 days. Changing a single repeating pattern means starting from scratch all over again. The idea is there, the tool is there, but the gap between the two feels impossible. What if you could simply describe that idea in plain language? And Grasshopper would build itself? Today, we go deep into how the combination of AI coding tool Cursor and Grasshopper is transforming the way architects work, and why this moment matters for every parametric designer on the planet. Parametric design has long been a discipline reserved for those who already know how to code. Grasshopper is extraordinarily powerful, but to unlock real automation, you needed to write Python scripts or C# components. That is a steep demand to place on a design professional. Surveys of architecture practices suggest that approximately 68% of professionals who attempt to learn Grasshopper abandon the tool before reaching genuine fluency. The coding wall is real, and it has kept algorithmic design out of reach for the vast majority of practitioners. Meanwhile, the AI coding tool market has exploded over the past 2 years, and Cursor has emerged at the center of that transformation. Cursor is far more than a smarter autocomplete engine. It reads your design intent, written in plain, natural language, and generates the Python scripts that Grasshopper understands for the first time. That wall is genuinely coming down. Cursor is an AI-integrated code editor built on the foundation of VS Code. It embeds large language models, including GPT-4 and Claude, so that non-developers can generate and modify code using plain, natural language. For architects, 3 capabilities stand out above all others. First, you describe your design conditions in everyday language, and Cursor immediately converts them into working Python code, no syntax knowledge required. Second, if your existing Grasshopper file throws an error, paste the full error message directly into Cursor, and it will diagnose the cause and present a corrected version. Third, complex multi-condition logic, such as distribute vertical louvers across this facade and reduce interior solar gain to below 30% on the winter solstice. With the angle varying floor by floor, gets translated into executable script in a matter of moments, at approximately $20 per month for a pro subscription. The return on investment is compelling when measured against the design hours it consistently saves. So how does this actually work in a live project? Here is a 4-step workflow that has been validated across real architectural practice. Step 1. Write your design intent as text. Be specific and concrete. Describe conditions like place vertical louvers on the south-facing facade, limiting interior solar gain to under 30%, based on winter solstice sun angles. The more precisely you articulate the constraint, the better the generated output. Step 2. Paste that description into Cursor and request a Python script. Attach any relevant context files from your project to help the model understand your setup. Step 3. Copy the generated code into a Python component inside Grasshopper and run it. Verify the result directly in the Rhino viewport before doing anything else. Step 4. If errors appear, copy the full error message back into Cursor and type, "Fix this error." On average, 2 to 3 iterations are all it takes to arrive at a fully working script. For a practitioner already familiar with this cycle, the entire process takes approximately 15 minutes, from first description to confirmed output. Let us look at a concrete example from practice. A mid-sized architecture studio working on a commercial office facade encountered a familiar bottleneck. Using conventional methods, manually adjusting louver angles and spacing floor by floor required 2 full working days. After integrating Cursor with Grasshopper, the same team completed a script that automatically optimized louver angles per floor based on live solar simulation data, accomplishing in 1 day what had previously taken 2. The more striking outcome, however, was the speed of revisions downstream. When the client changed the louver profile specification, partway through the project. What had previously been a half day of manual rework was resolved in under 3 minutes. The team entered the updated condition into Cursor, and the entire facade updated automatically. The time saving was significant, but the deeper shift was psychological. The fear of design changes effectively disappeared. Iterations stopped feeling like a cost and started feeling like an opportunity. The Louvre facade is just the entry point. The true scope of what the Cursor plus Grasshopper combination enables across architectural practice is far broader, and the global industry is only beginning to explore it. First, structural optimization. Feed load conditions into Grasshopper via a Cursor-generated script and receive an automatically optimized truss or shell geometry in return. Second, interior module design. Ceiling patterns and partition systems can be automatically arranged to fit any spatial dimension, with quantity takeoffs generated in the same operation. Third, direct BIM control within a Rhino.inside environment. Cursor-generated scripts can drive Revit models directly. Autodesk's own generative design toolset already demonstrates that algorithmic workflows can automatically produce hundreds of distinct floor plan alternatives from a single set of constraints. The same principle now extends to fully custom parametric scripts built in minutes. Fourth, automated drawing extraction. Once a parametric model is complete, plans, elevations, and sections can all be batch exported in a single automated pass. Research indicates that AI-assisted CAD workflows can cut initial design drafting time by up to 73%, with governments in countries including the United Kingdom and Singapore having mandated BIM on public projects for over a decade. Script-driven parametric automation is no longer just a competitive edge for firms working across borders. It is becoming an operational baseline. The combination of Cursor and Grasshopper is not simply a story about productivity gains or faster workflows. It is a signal that the language architects use to express design ideas is itself fundamentally changing. Learning to code was never the goal. The new literacy that will define the next generation of architectural practice is the ability to communicate design intent clearly, precisely, and effectively to an AI, to translate spatial and structural thinking into language a machine can act upon. That is a skill architects already possess in abundance. It simply needs to be redirected. The threshold to begin has never been lower. Install Cursor for free. Choose the single most repetitive task in your current Grasshopper workflow. Describe it in plain language, and let the AI attempt it. The gap between the idea in your mind and the geometry on the screen is narrowing faster than most of the profession realizes. What is the one design repetition you would most want to automate first?